Assalamualaikum and hi everyone. Okay, so this video should explain everything about the basic introductions to organic chemistry, which I will answer all the questions that I give to you in the Google Classroom for our first hour tutorial of this week. Okay, so we're going to learn on how to draw different types of structural formula for your organic compound. So basically there are three types of structural formula. One is condensed formula, secondly is expanded structure, and thirdly is the skeletal structure. So let's go through these first questions. Okay, the question number 1 here. You were given this is a skeletal structure. Okay, if you see only the picture of a bone and a special kinds of functional group, so that means it is a skeletal structure. Okay, so all of these 4 molecules given here are skeletal structure. Okay, which is the simplified versions of structural formula of an organic compound, which we only going to show functional group that is present. Okay, or other atoms other than your carbon and hydrogen. Other atom beside carbon and hydrogen. So only special types of atoms will be shown in your skeletal structure. Okay, because carbon and hydrogen are basic atoms that made up an organic compound. Okay, let's look at the first chemical structure. Alright, so we have here. Okay, so first, whenever you want to try to write down a condensed structure, okay, you first need to find out how many carbons that is present in your organic compound. Okay, so we should starting labeling by this is the first carbon, second, and third. Okay, the one that is extended here, we name it as a branch or chain. Branch chain. Okay, alright, so in this one we have only one carbon. Okay, so a condensed structure is a simplified version of expanded structure. We shows all the atom that is present, okay, but we don't included all the bonds that is forming. Okay, so for this one, okay, so I have 3 carbons at the backbone. So first carbon, second carbon, and the third carbon. And at my first carbon here, okay, and my first carbon, we have OH functional group attached to it, so OH. Okay, so let's fill up with others. Okay, and at the second carbon, okay, here we have a branch here, so C, another C. Okay, so let's fill up the gaps with hydrogen that is present. Okay, so each carbon should have 4 bonds. Okay, okay, so this is the expanded structure for your first compound. Okay, so if I want a condensed structure, I'm going to simplify. So at the first carbon we have CH2 and it's attached to OH. Okay, at the second carbon I have CH, okay, with a branch of CH3. Okay, so you're going to put brackets to show branch. Okay, and the third carbon we have CH3. Okay, so this is your condensed structure. Whereas this is your expanded structure, where expanded structure you choose all the bonds that is present. Okay, and the first here is your skeletal structure. Alright, so let's look at the second compound. Okay, so we have in the compound 2, we have 6 carbon that makes up the backbone, okay, with 2 side chains, okay, which is at carbon number 2 and carbon number 4. So we have special functional group which is C double bond O at the third carbon. Okay, so how to write down the condensed structure for this compound? Okay, so we have 6C Okay, and at the third carbon we have C double bond O. Okay, side change CH3 at both carbon number 2 and carbon number 4. Okay, so whereas the rest of it just follow the same thing, which is the first one we have CH3, so CH3, and okay, and then at C double bond O is already have 4 bonds around it. Okay, so CH3, and then CH2 at the 5th carbon and CH3 at the 6th carbon. Okay, so let's rewrite CH3, CH3, C double bond O, CH3, CH2, and CH3. So this is the condensed structure for your second compound. Okay, so your third structure is cyclic structure. Okay, so we have here 1, 2, 3, 4 carbon that's made up your cyclic structure. Okay, so for the structures okay, for if it's a cyclic structure, so your condensed structure will looks like this. So we have here CH double bond CH, okay, and then CH2 and CH2. That is for your third compound. So 1, 2, 3, 4. So 4 carbon that's made up the backbone with a functional group of OH at C double bond O and Cl. Okay, so we have for the first carbon we have CH3. Okay, and the second carbon we have CH with a side change of Cl. Okay, so you can put Cl in the bracket. Okay, and then for the third carbon we have CH2. For the fourth carbon we have C double bond O, OH. Or alternatively, okay, you can also write it as CH3, CH, and then this Cl shows the functional group that is present, CH2, C double bond O, OH. Or the C double bond O, OH, okay, you can also simplify to make it like CH3, CH, okay, Cl, and then CH2 and COOH. Okay, so these are the 3 options for answering question number 4 for the condensed structures formula for this compound. So there are 3 different ways, but all of it are considered correct for your condensed structure. Next questions, instead of writing down the condensed structure, now you will given a condensed structure and you need to draw the skeletal structure for the given compound. Okay, so in order to draw the skeletal structure, you need to find out how many carbons is present for the backbone. Okay, so let's look at the question number 1. So we have here 1, 2, 3, 4, and 5. So 5 carbon at the backbone. Normally, we will start to count the number of carbon from with the one that give the smallest number for your functional group, but worry not. Okay, you will understand more about this later on when you start to give a name for your chemical compound based on IUPAC name. Okay, so now our focus is just to learn how to draw your structure, okay, according to skeletal, expanded, or condensed, and this one is skeletal. So question number 1, okay, so there are 5 carbon, and at the 4th carbon we have C double bond O. So let's make 1, 2, 3, 4, 5. Okay, at the 4th carbon we have here double bond O. Okay, so that is for question number 1. Whereas for question number 2, so I have here 1, 2, 3, 4, 5, 6, 7. So 7 carbon, okay, and at the carbon number 2 and carbon number 5 we have side change, which is CH3 and CH3. Okay, so 7 carbon makes up the backbone. So 1, 2, 3, 4, 5, 6, 7. Okay, and at the carbon number 2 we have CH3 side chain. So methyl group here, number 2, 1, 2, 3, 4, 5. Okay, so another one here. So that is for your question number 2. Okay, question number 3. Okay, so CH3, 3. Okay, so it's here 1, 2, 3, and 4. Okay, so 4 carbon are the backbone. Okay, so 1, 2, 3, 4. Okay, at the first carbon we have functional group OH attached to it. Okay, so get a bond here to plot OH here. Okay, and then at the fourth carbon we have 3 side chain of methyl groups. So it's like this. Okay, so these are the skeletal structure for question number 3. Okay, let's move on to question number 4. Okay, so we have here 1, 2, 3, 4, and 5. 5 carbon with functional group of COOH, and another one is bromide ion at carbon number 3. Okay, so 5 carbon as the backbone. So 1, 2, 3, 4, 5. Okay, and the first carbon I have here C double bond O, so double bond O, and then OH. Okay, and at the third carbon I have Br, so first, second, third, so this is your Br. So that's how you draw your skeletal structure. Given the skeletal structure, and you need to come up with the expanded structure as well as the condensed structure. Okay, so let's do first the expanded structure. Expanded structure means you need to show all the bonds, how the atom is connected with each other. Okay, so we have here 1, 2, okay, and then this is your benzene ring. So your benzene ring is made up of C, okay, and then C. There are 6 carbon made up your benzene ring. Okay, with double bond here. Okay, and then at this carbon on the top, okay, we have another C which attached to C double bond OH. Okay, shows all the bond that is present, including separating O and H by a bond. Okay, so here I'm going to complete the structure by make sure all my carbon has 4 bonds. So any missing bonds means that the carbon is connected with hydrogen. So here 1, 2, 3, 4. Okay, 4 made up this. Okay, so this is the expanded structure. Okay, so let's write down the condensed structural formula for this compound. Okay, so we have here C. Okay, I'm going to maintain this C double bond OH. Okay, so let's write down the condensed structure for this compound. So C, so we have here COOH. Okay, and then here I have CH. Okay, CH. And this one CH as well. CH and CH. Okay, please make sure you have a complete all the bonds that is present. Okay, so that is for your first compound. Let's move on to the next compound. This one, you were given a condensed structure and you need to come up with the expanded structure and the skeletal formula or skeletal structure. Okay, so let's count the number of carbon that is present that makes up the backbone. So we have here first carbon, second carbon, okay, third carbon, and here at the third carbon we have 2 methyl groups attached to it. Okay, at the second carbon we have 2 branch. One is your bromide ion or bromine, another one is your methyl group. Okay, so let's draw the skeletal structure first. So we have 3 carbon, 1, 2, and 3. So we have 3 carbon here, 1, 2, and 3. At the second carbon I have bromine and a methyl group. Okay, whereas at my third carbon I have 2 methyl group. So it looks like this. Okay, whereas let's draw your expanded structure. Okay, so first C, second C, third C. Okay, on my first C, I only have hydrogen attached to it. On my second carbon, I have bromine and another methyl group. So shows all the atoms and the bonds between them. Okay, at my third carbon, I have hydrogen here, and then I have two methyl groups that is present. Okay, okay, so these are the expanded structure for my second chemical compound. This one, you were given an expanded structure, so you need to come up with the skeletal structure and condensed structure. Okay, so first, you need to count how many carbons that made up the main backbone. Okay, so first, second, third, fourth, fifth, sixth, and seven. So 7 structure. Okay, so, and we have one side chain, your methyl group at the third carbon. Okay, it's easier to write down the condensed formula first based on the given expanded structure. So under 7 carbon, we have CH3. Okay, and then 6 carbon, CH2. At the 5th carbon, only CH2. At the 4th carbon, we have CH and a chlorine as the side chain. So put it in the bracket. So it's chlorine. Okay, and then CH at the 3rd carbon with a side chain of a methyl group. So write it down CH3. Okay, and then 2nd carbon we have CH2, and the last one we have CH3. Okay, and this is the condensed structure. For the skeletal structure, so 7 carbon. So 1, 2, 3, 4, 5, 6, 7. Okay. At the 3rd carbon, we have a methyl group. So 1, 2, 3. So 1 methyl group. And at the 4th carbon, we have chlorine. Okay, so these are the condensed structure. And this is your skeletal structure. Let's move on to the last question. Okay, as usual, we need to start numbering the carbon. Okay, so 1st, 2nd, 3rd, 4th, and 5th. So on my first carbon, okay, I have double bond O, and then O with OH, which is for your COOH. And then we have 2nd carbon, which have Cl as the side chain. Okay, the 3rd carbon, nothing except hydrogen. Okay, so between carbon number 3 and carbon number 4, there is oxygen. Okay. Okay, at the 5th carbon, we have 1 bromine, and another one, we have CH3 or your methyl as the side chain. Okay. So this is the expanded structure. Now I'm going to simplify the expanded structure to transform it into a condensed formula. So we have COOH, okay, followed up by CH, okay, with a chloride ion as the side chain, okay, and then CH2O, CH2, CH, okay, in the bracket CH3 and Br. So this is the condensed formula for your chemical compound. Okay, it will be very easy for you to do the structural formula if you understand how many number of bonds that an atom can make. Okay, the number of bonds is different for different atom. Okay, so number of bond, okay, for carbon, so there should be 4 bond. Okay, whereas hydrogen, we only can form 1 bond with another atom. For oxygen, okay, we can form 2 bond with another atom. And then, okay, so other halogens like chlorine, bromine, iodine, okay, and fluorine, all of these will only can form 1 bond with another atom. Okay, another common atoms in your organic compound is nitrogen, which a nitrogen can form 3 bond. Okay, this bond that I'm referring to, including single bond, or double bond, or triple bond. Okay, so how do we calculate the number of bond? For example, if I have this carbon attached to another carbon, and this one is the first bond. Okay, single bond. So that means in order to complete the compound, the structure, I'm going to fill up with another atom here. Okay, and to fill it up with another atom. So this carbon should have 4 bonds around it. Okay, so it can be with attaching to hydrogen or another atom. Okay, another things. Okay, if it's a double bond, let's say C double bond C. Okay, so that means in order to make it a complete structure, my carbon will need to form another 2 bonds with different atoms. So it's like this. Okay, so the atoms can be hydrogen or any other substance. Okay, so for special functional groups such as C double bond OOH, okay, so C double bond O, O and H. Okay, so this carbon we have 1, 2 and 3 bonds around it. That means I'm going to form another 1 bond with another 1 atom. Okay, so for this oxygen, it already achieved 2 bonds on it. Okay, and this oxygen too has 2 bonds. Connect 2 bonds on it, so connected with 2 different atoms, and this hydrogen already have a complete arrangement with 1 bond attached to it. That's how you calculate the number of bonds that is attached to one atom.